Why does division by zero crash automated processes? Imagine running a machine that processes data nonstop, and suddenly it stops working. One common reason for this is trying to divide a number by zero. It might sound simple, but it causes big problems in automated systems. When a program tries to divide by zero, it triggers a runtime error. This is because division by zero is mathematically undefined. No matter what number you use, dividing by zero just doesn't make sense in math. In programming, this undefined operation is treated as a critical error. Most programming languages and runtime environments see it as something that can't be resolved during execution. When the process hits a division where the denominator is zero, it immediately stops. This prevents the system from producing incorrect results or corrupting data. Think of it like a safety switch that kicks in to stop the process from going off the rails. Let's look at why this happens. In math, dividing any number by zero has no answer. For example, if you try to divide 10 by zero, there's no number that you can multiply by zero to get 10. It simply doesn't exist. In programming, this leads to a runtime error called a division by zero error or an arithmetic runtime error. Most languages don't handle this automatically, so the error causes the program to crash or halt. Automated processes often handle critical data or transactions. If they allow division by zero to go unchecked, it can lead to wrong results or even data corruption. That's why systems are designed to stop and report the error instead of continuing blindly. It's a safeguard to keep everything reliable. Different environments react to division by zero in their own ways. In SQL databases, dividing by zero causes the query to fail and might roll back the transaction. In languages like C++, dividing by zero throws an exception, which if not caught, crashes the program. Some languages like Julia might return special values like infinity instead of crashing, but that can cause other bugs if not managed carefully. Common causes of division by zero in automated processes include unexpected data inputs. For example, if a process calculates averages or ratios and the denominator becomes zero, it crashes. User inputs or external data sources that include zero values without validation are also common culprits. Sometimes, logic errors or uninitialized variables lead to zero denominators, causing crashes unexpectedly. To prevent this, always check the denominator before dividing. Use conditional statements to test if the denominator is zero and handle it accordingly. For example, you can replace zero with a safe value or skip the calculation. Exception handling is also useful. Wrap division operations in try-catch blocks to catch errors and handle them gracefully. This way, the process can continue or report the problem without crashing. Testing your code with edge cases that include zero denominators helps find these issues early. Logging errors and setting up alerts can notify you when division by zero occurs, so you can fix the data or logic. When debugging, locate where division happens in your code, trace the values leading to zero, and add checks or exception handling around those spots. Understanding why division by zero crashes automated processes helps you build more reliable systems. Always validate inputs, handle exceptions, and test for these edge cases. This approach keeps your processes running smoothly and avoids unexpected shutdowns.